Okay, so this guy is divergent. I guess you could say more specifically, you get some plus infinity here, don't you? Okay, let's do some more difficult examples. So what first? How about an is equal to n squared over n factorial? Okay. Now, don't try to use L'Hopital here. The function n factorial is not a, it's only defined for n. Well, for now, it's only defined for n an integer. Is it defined for n a rational number? Maybe I'm thinking of something else. Anyways, for us at least, n factorial is only defined for n a positive integer. So you certainly can't use a function like x factorial and do a derivative. Anyway, it's not going to happen. We have to attack this directly. So what I'm trying to do here is figure out who wins this battle. Okay, n squared and n factorial, they're both going to infinity. I'll remind you of what n factorial is. 3 factorial is 1 times 2 times 3. 5 factorial is 1 times 2 times 3 times 4 times 5. I think that summarizes it pretty well. So n squared and n factorial are having a fight. Who is going to win? They're both going to infinity, but who is kind of growing faster? Well, why don't I write this out, expand this a little bit, and I get 1 times 2 times 3, 3 times 4, n minus 2, n minus 1, n. And then on top I have, n times n. So what I'm going to do is try to group things together here to see if I can't make some progress. What I'm going to do is I'm going to put all of this together. Now, why would I do a thing like that? Well, it's not my first rodeo. And I've learned a few tricks. Okay, now that I've grouped it like this, what do I see? Well, I see that, it's pretty plain to see that the limit here is going to be 1, and the limit here is going to be 1, and the limit here is going to be 0. Okay, that's clear, hopefully, to you. Oops, arrow. Okay, so my sort of factoring here has allowed me to conclude that the limit is going to be 0. Okay, so n factorial does win this battle. Okay, next. More factorials. This one's a little bit easier. Okay, factorial over factorial. Okay, just have to remember how to cancel these properly. So 1 times 2. On top, I got 1 times 2 times 3, all the way up to 2n, and then 2n plus 1, and then 2n plus 2, and then 2n plus 3. Okay, why is that? Well, 2n plus 3 factorial over here Okay, just think of it as a product that starts at 1 and ends at whatever number you have here. So in our case, it starts at 1 and ends at 2n plus 3. Now, as it goes from 1 to 2n plus 3, it goes up by 1 each time. It eventually arrives at 2n, and then the next one is 2n plus 1, and then 2n plus 2, and finally 2n plus 3. Okay, on the bottom, 1 times 2 times 3. This one is only going to make it as far as 2n plus 1. Okay, now that I've written that out, I can see what cancels. All this is all canceling. And I get 2n plus 2, 2n plus 3. And the limit here is obviously plus infinity. So I want you to say divergent if you're going to do this arrow infinity thing. Okie dokie. Another example. Which I will pick up in my next video, because this one's a little bit tricky. I want to do it nice and smoothly for you.